In lesson 8.4 video clip. This should be a relatively short video clip. Some of you might have gotten this information from the book. But for now, we're just looking at what angles of elevation and depression are. You'll be applying these vocab terms to problems with a partner in class during the next lesson. Learning targets. Can you identify angles of depression and angles of elevation? That's what we're focusing on in this video. Can you use angles of elevation and depression paired with your knowledge of right triangle trigonometry to solve for distances and heights in real-world problems? We will look at one problem that says example, but I'm going to see if you can pause the video to try and set it up and solve it, and then I'll go through it. Can you solve multi-step problems using angles of elevation or depression? This will come later during our partner practice and exploration. Identifying angles of elevation and angles of depression. An angle of elevation is I should say, instead of is, would be as seen by an observer is the angle between the horizontal line from the object to the observer's eye. The angle between the horizontal and the line from the object to the observer's eye. You may have copied a slightly different variation of these words from the textbook, and that's fine. In this particular diagram, angle 1 is the angle of elevation, because from tower T, if the observer sitting there looked straight out, that would be the horizontal line, but they're not looking straight out, they're looking up, and that's their line of sight. So from the horizontal to that line is the angle of elevation. Angle of depression. Angle of depression is as observed, or is the angle formed from the horizontal to the downward line of sight. Downward line of sight. Again, your book may have had a slightly different definition. So if you're the person sitting in the plane up here, or you're the tip of the plane, and you were looking straight out, that would be the horizontal. And then now you're actually looking down at the tower though. So your line of sight goes from what would have been you're looking straight out to now you're looking down. So that would be angle 2 in this diagram is the angle of depression. Now, real quick, should be an observation you can make here. There's a horizontal line and that's a horizontal line. So guess what they are? Yes, parallel. So what's that make angles 1 and 2? Well, if you know what angles they are, then you know something about angles 1 and 2 and a reason why. If not, be sure to ask about it in class. Take a moment to try to classify each of these angles, okay? Angles 3, 4, 5, and 6. So pause the video and try those. Angle 3 is an angle of depression because from the horizontal to the line of sight, we would be looking down. Down from horizontal. Angle 4 is this angle right here. From the horizontal to the other edge of that angle, you're going up. So it is an angle of elevation. Because it's up from the horizontal. For similar reasons, angle 5 is an angle of depression. because from the horizontal line of sight, they're looking down. And angle 6 is an angle of elevation. From the horizontal line of sight to the line of sight, you're looking up. Angles 5 and 6, they ask how are they related? Well, you may have already said it before. Angles 5 and 6 are alternate interior angles. So that means, and those are horizontal lines are congruent, then they're congruent, or sorry, they're parallel, so the angles are congruent by the alternate interior angle theorem. Here's an example, but I don't want to give it as an example. I want you to see if you can draw a picture first. And we'll talk about the common error and look at how to solve it. So don't solve it, just pause the video and try to set up the problem real quick. Welcome back. Forest ranger in a 90-foot tower. So here's what most people screw up on. They draw this nice little picture, and so they have their little tower. Here's my tower. It has a deck, so there's the deck, here's the roof line. And there's the forest ranger. They're standing at the top of this tower. It's a 90-foot tower. And they're looking out, and all of a sudden they're looking down, and they see, because we know they're looking down because it's an angle of depression, a forest fire. So maybe there's some trees in there too. So there's trees in our forest fire. So here they are, they're looking down. So we do have a triangle formed by their line of sight and where the forest fire is and where they're located. So we have a right triangle, the tower is perpendicular to the ground. Now this is an angle of depression. The common mistake is for people to put the angle here. They're like, oh, they're looking down, there's my 7-degree angle. That's not an angle of depression. The angle of depression is from the horizontal line of sight. From the horizontal, if they were looking straight out, to the line of sight. So this is the 7-degree angle. This being a right angle up here, since that's a horizontal line and this is a vertical, this angle right here is actually 83 degrees, so that those two would add to 90. The 7 degrees does not belong up here. Most people forget that, so whenever you encounter an angle of depression, if you are likely to get confused by that, hopefully you don't now that we've gone over it, I say, you know, when the angle is depressed, it might be sad. But we can turn that frown upside down and make it an angle of elevation, because we really have alternate interior angles here. So our angle of depression will be the same measure as if we were sitting at the other location and viewing it as an angle of elevation. So turn that frown upside down and make it an angle of elevation, and you'll be able to solve your problem. We know the tower is 90 feet. So they're asking, what's the horizontal distance between the tower and the fire? They could have also said, what's the length of his line of sight? Not that that helps, but maybe if it was a zip line problem, we could zip line down there. But you wouldn't want to do that into the fire. So see if you can solve this problem using trigonometry. You know the 90 degree, we're going to pretend we don't know the 83. We know the 7-degree angle, we know the 90 feet, solve for this side. If you did this correctly, you should have done tangent of 7 degrees equals 90 over x. Cross multiply, 90 equals x times tangent of 7 degrees. Divide to solve for x, 90 divided by tangent of 7. Is 732.99. So if we're doing to the nearest foot, 733, roughly 733 feet away. So that fire is not very far from where the tower is. It's a little far, but not anything too horrible. He should be able to get there, hopefully. Hopefully it's a small fire. This concludes the video lesson for 8.4. You'll be doing some partner problems in class. Please do not work ahead. This was intended to be a short